at slightly higher power, smoke is coming out over here. It's getting so hot. Argon ions inside, discharging like a capacitor. Argon ions outside, spinning as an arc. What we're looking at now is a slightly modified device where the central electrode sticks out a bit with argon ions on it, and we place it so it's just entering this magnetic field. We see a huge flame. Without any magnets there, all we see is an arc between the two electrodes. Negative in the center and positive on the outside. When we add the magnets back in, the arc starts to spin and release. Quite a nice flame, isn't it? Now when we build a ring of permanent magnets like this, 9 stacks of neodymium magnets built into a ring, they're repelling one another quite strongly in the center. Above the ring we just get what's called axial magnetic fields, like north-south, and that makes the argon gas spin sideways. And then we go into the field, the magnetic field goes sideways radially, and that's where the argon gas gets ejected like a rocket, where we change from axial to radial. So when a test magnet is above or outside of the ring, you can see it stays a flat interaction when the gas spins. That's called an axial field, where it's horizontal. And then when it gets on the side of the ring like this, it turns sideways, and that's called a radial magnetic field. This is clearly a rocket flame coming off the central electrode, which is negative. And you see all the blue argon ions when we put the start of the magnetic field just near the start of it. And you can hear the ratchet sound. That ratchet sound comes about when the argon ions leave the central electrode there and jump off to the wall of the tube where the radiomagnetic field is located, rather than back here spinning with the Corbino disk. So it can either interact with the Corbino disk, or it can interact with the radiomagnetic field. That's a spin motion, axial, and that's a radial motion as the character of the magnetic field changes. If you look closely, you can see the argon ions jumping from that central electrode, not back to the Corbino disk over here, but forward along the walls of the tube and being ejected from there to there, going out, and that's what's causing the ratchet sound. If we pull it away from there, we just get spin. Then the spin motion converts to that ratchet motion as it goes forward into the radio field. There's no extra capacitor here, just 300 picofarad of the power supply. We flip the polarity, we see a spinning arc, argonines outside. Flip it back, argonines inside, we see a ratchet motion. Argonines inside, discharging like a capacitor. Argonines outside, spinning as an arc. Argonines inside, discharging like a capacitor. Argonines outside, spinning as an arc.